So this is our group presentation for mechanical lab 4 as for gyroscope. So first of all, I'd like to introduce myself and my group members. My name is Naunida Anlaki Mutia. My group members are Muhammad Irfan, Siti Aisha, and Iyad. So now we're going to look at the introduction of the gyroscope. So as for this lab, we were required to design 3 short experiments by using toy gyroscope to examine the effect on number of coil, mass, location of mass along the shaft on the precision speed. Next slide, please. So this is the theoretical background for this gyroscope experiment. So the equation below, the equation over there showing the behavior of the gyroscope. So if the top is placed on a flat surface near the surface of Earth at an angle to the vertical and is not spinning, it will fall over due to the force of gravity producing a torque acting on its center of mass. If the top is spinning, it will precises about z-axis. So this is the formula for torque, and the precision angular velocity will be calculated using this equation. So that's all from me.
So thank you, Nova. Also, we proceed to the material and apparatus. So in conducting this experiment, we need actually 4 materials and apparatus, which is the gyro toy, load. As you can see from the picture, it has 10 steel ball, which each ball weight about 1 gram, thread, and a clay. Clay is used to stick to the base of the gyro toy, so it did not move. So based on this video, this is how we basically do this experiment. So this is the experiment 1. This experiment 1 is basically we manipulate the value of the number of the turns with a fixed angle, which is 90 degree. So after we put it, and we insert the gyro toy inside its frame and put it in the base. So for the experiment 2, which is the weight of the load. For the first load is 2 gram, which is the 2 steel ball, and for the second weight is 4 gram, and the third weight is 6 gram. So for the experiment number 3 is the position of the load. So we decided to make 3 gram of load situated in different places, which is the top, the bottom, and the middle of the gyro toy. So I think that's basically how we do the procedure. So proceed to the result. Thank you.
Okay, thank you, Irfan. So I will continue with the result. Okay, so for the first experiment, and for all the experiment, we fix the angle to be 90 degrees. So for the number of turn 50, the time for the gyro toy to fall is 13.2 seconds, and for the turn of 20, the time is 16.5, and for the turns 25, the time is 70.1. Okay, next. Okay, so we use the precision speed formula to get that answer. Next. Okay, so for the experiment 2, we fix the number of turn to be 25 and the load in a fixed position. So for the load 2 gram, the time to fall is 17.7 second. For the load 4 gram, 15.4, and for the load 9 gram is 16.3. Next. Okay, so we also need to calculate the precision speed for that experiment as well. So next. Okay, so for the experiment 3, we fix the load to be 3 grams and the number of turns to be 25. So the positions at the top, the time taken for the gyro toy to fall is 7.7 seconds. When we put the load in the middle, the time taken for the gyro to fall is 5.9 seconds, and at the bottom, the time for the gyro to fall is around 0 to 1 second. Okay, next.
So for the discussion, based on the result that we obtained from the experiment 1, we can see that the number of turn increase. And when the number of turn increase, the angular velocity of the gyroscope also will increase, while the precision speed is decreasing. This can be seen in the when the angular velocity is 7.14 radian per second, and the precision speed is 104.11 radian per second when the number of turn is 15. So as the number increased to 20, the angular velocity increased to 7.62 radian per second, and the precision speed is decreasing to 97.55 radian per second. Next. So for the experiment 2, we can see that the precision speed increase as the load of the on the gyroscope is increasing. This can be seen when the 2 gram of load is added to the gyroscope. The precision speed increased from 83.38 radian per second to 85.86 radian per second. So based on the result on the experiment 3, we get to know that the higher the position of a load, the more the time taken for the gyro toy to fall. In this experiment, the angle, which is 90 degrees, number of turn of 25, and the weight of 3 gram is fixed for all the positions. So, in conclusion, we can say that the effect of spin speed, mass, and the location of the mass along the shaft can be examined by using the gyroscope. So with that, that concludes our presentation, our group presentation. Thank you.